Assalamu alaikum warahmatullahi wabarakatuh. Today we are going to explain double integral over rectangular and non-rectangular area in the Cartesian coordinate. So we'll solve some exercise in details to show you how to sketch the area and also of the integral, and also different type of exercise. You have exercise only from 1 is rectangular area because you have a constant values for x and y. 2 also. 3 is rectangular area. 4 also is rectangular area because you have constant lower bound and upper bound for x and y. But when you go down here for number 5, so 5 to 10, all of them are non-rectangular area because you have some function, and if you notice that the function will be inside integrator but not for the outside integrator unless you mention different from this one. Okay, this is from 1 to 10. From 11 to 16 he's not going to write you the double integral, you will write it yourself. Depends on the function, and depends, you will start with dx or dy. Okay, this is from 11 to 16. From 21 to 30 he give you double integral non-rectangular area. Okay, and you would like to see how you're going to solve this one similar to 1 to 10 then with non-rectangular area. Next you have to evaluate double integral after you sketch the region from 31 to 40. Okay, and also you have to reverse the integration. Sometimes without reversing you can integrate, but sometimes it's really difficult, very similar to this one, 31. You cannot integrate sine y over y with respect to y, even if you have one variable function. Okay, yes, you will say maybe I'll try by substitution. You cannot. By parts you cannot. So there is no integration methods you can use to integrate sine y over y with respect to y. So I cannot integrate with respect to y first, so I have to swap dy with dx. Swapping dy by dx, which means reverse the order of the integration. Not easy to do this one. You have to sketch your graph, right, or your area, sorry, the graph of your area, and then you start evaluating the lower bound and the upper bound of each y and x. Depends on the area you sketch it from the lower bound and upper bound for every independent variable x and the other independent variable y, because we have two independent variables because we are working in two variable functions. Okay, this is the function with two variable under non-rectangular area when I need to reverse the order of the integration because I cannot integrate first with the dy in 31, also in 32. Yes, you can integrate with respect to x, but you cannot integrate with respect to y because you have 2y squared and sine x1. You said the integration by parts, yes, but you still have x inside. Okay, try it and let me know. Okay, so we can try this one also by MATLAB just to check. Let's start with this Yes, we have this question, which is number okay, I'll just write down this one and then you need to know how to do this one. So, okay, I'll get back to the exercise. At the next page of the exercise in your e-learning, you will find some exercise you have to use computer algebra system, which is called CAS as abbreviation. Okay, and today, now we are going to integrate from 0 to root square x for the function. How to find this one from y. For y, you get y equal to 0 and y equal to root square x. So I know the first part of the region, okay, and for x equal to 1 and x equal to 5. Shall we try to sketch the graph? I go for x-axis, horizontal coordinate, y-axis is the vertical coordinate. X from 1 to 4, so I need only 1 to 4, so I have to extend x a little bit just to have space for 1, 2, 3 to 4. That's enough. Okay, now I need only y from 0 to this one. What is the equation? What is the equation of this one? The equation is y squared equal to x. This is a parabola, but this parabola is vertical or horizontal one, open to the right, to the left, or up and down. This is horizontal parabola, because I have two values of y, the positive value of y and the negative value of y will have only one value for x, so it is symmetric with respect to the x-axis. Half of the parabola will be above
دكتور
x-axis.
هذا السؤال حليناه.
Okay, I will repeat it again, no problem. Okay.
Okay.
So I have the parabola open to the right because I have positive root square x, so I should have the upper area of the parabola. If I have negative root square x, I will take the down one. Okay, now this is, I sketch my region. I'm going to integrate over. Okay, I call my integration as I instead of writing it again. So the I will equal to the integration of this one. Remember, first I'm going to integrate with respect to y, so I consider x as a constant, so I don't worry about the root square of x down the y. It will be like a constant, like any number. The 3 over 2 also is a constant, I can take it outside, and the integration of e to the over y over root square x, it is e over the derivative of this power with respect to y. As I said, x is constant, so I can have it down e to the, which is a derivative of y over root square x with respect to y would be 1 over root square x. Okay. Don't forget the 3 over 2, which is a constant up here. Okay. is outside. Okay, I substitute by y equal to root square x, so I have root square x over root square x will be 1, and e to the power 0 will be 1. So I have e to the power x over the root square x, it will be e to the power 1. This is the upper bound substitution minus the lower bound substitution, which is 0. E to the 0 will be 1. Now I cancel out this one. So again, I get back to the page. Okay, again. Yes. This is our integration. It is about 0 is 1. Root square x over root square x in the exponential function over here will be 1. I'm just substituting by this one. Now let's go for 25. Integrating from 1 to e to the x with respect to the y first, and then integrating from 0 to 1 for dx. First, I'm going to sketch the area, how to find the area. I'm looking at y. Y, the lower bound is 1, so y will be start from 1 and end with e to the power x. What about x? X start from 0 to 1. So I write the equation for my area or my region. Here is x-axis and y-axis. X is 0 and x is 1. Easy to put it in the x-axis. Y is 1, start from 1. Okay, when x equal to 0, I have the relation between x and y explained by the curve y equal to e to the x, which is an exponential function. And I know this exponential function, if x equal to 0, it will be e to the power 0, which is 1. So I will start from 1. And then I end up with x equal to 1. So when x equal to 1, I have e to the power 1, which is e. So what is my region now? My region is bounded by 0 to 1 for x and y equal to 1 in this area. Okay, so my region will be y from 1 to this curve. So I'm going to shade it. Yes, here it is. It is my region explained by the lower bound and upper bound for each y and x. Again, I'm going to sketch it again. Okay, x and y. 0, x start from 0 to 1. Y start from 1. And y is exponential function. And I know exponential function start from 1 when x equal to 0 and go up. But I'm not going to take all of it. I'm start from x equal to 0 to 1. So when x equal to 1, I know y equal to e to the x. So it will be e to the 1. So this is my area. Now let's go for the integration. Easy. When I integrate dy, I will have y. Okay, so I'm still having the integration from 0 to 1 for dx, but dy has integration y. And don't forget to substitute by the lower bound and upper bound. You substitute by the upper bound first, so it is y equal to e to the x, so I replace y by e to the x, minus the lower bound, y is equal to 1, so minus 1. I call the integration I instead of typing all the time the whole integration. Now I finish integrating with respect to 1. I will go to integrate with respect to x, which is easy also. The integration of e to the x is e to the x. The integration of minus 1 is minus x. Again, I'm going to substitute by the upper bound, which is x equal to 1, minus the substitution by substituting by the lower bound, which is 0. E to the 1 is e minus 1, because x is 1, minus the substitution by x equal to 0, e to the 0 is 1, minus x is 0 minus 0. So this is my final result. Okay, matter asking me to solve 34. Let's go for 34. Okay, shall we type 34? I know it is double integral. From 0 to 4 minus x squared. So it means the inside one will be dy. Once I have a function of x, I'm sure the inside one start with integrating with respect to 1. And the outside one will be x from 0 to 2. But what is the function I'm going to integrate in 34? X e to the 2y over 4 minus y. As I said, dy dx, because I have a function of x inside, so the inside integrator will be dy. Again, the outside integrator, dx, should have only constant value, right? But the inside one is dy as a y as a function of x. So I'm integrating over non-rectangular area. This is why I have a function of x inside, because inside I'm integrating with respect to x. This is the lower bound y equal to 0. The upper bound is y equal to 4 minus x squared. This is part of my region, which I'm going to sketch. And x from 0 to 2, which is vertical line. X equal to 0 is y-axis, x equal to 2 is a vertical line parallel to y-axis, and y equal to 0 is x-axis, y equal to 4 minus x squared is a parabola. But let's check how to find the relation between x and y. I have x from 0 to 2, y 0, so I have no problem. How to explain this parabola? I am looking for y equal. I would like to know, I can move y in one side to have if I have x equal to 0 from the relation between y and x, this one, so I will have y equal to 4. That's fine. And also I have it 4, and also when x equal to 2, I will have 4 minus 4, which is 0. So this is my start and end point for the area, and this is a parabola. This is why I make a curve from 4 to, y equal to 4 to y equal to 0, or from x equal x and y equal to 0 and 4 to 2 and 0. How I get this one? I get it from the relation. No need to substitute anywhere. You substitute in the relation between y and x. You don't care about y equal to 0, but you're caring about the relation between y and x, which is explained by y equal to 4 minus x squared. How I got this one? I got it from the inside integrator dy, because I know y equal to 0 to y equal to 4 minus x squared. So I substitute by x equal to 0 and x equal to 2. I know the start point and the end point. Why I make a curve? Because I know this is a parabola. Clear? Okay. So again, I know it is a curve. this parabola, but with the head at x equal to 2 and y equal to 0. Let's go for the integration. Yes, I'm lucky because all of these things, including only y, which is e to the 2y over 4 minus y, it will be, for me, it will be a constant. Yes, all of this one, I don't care about it. I can take it as a constant, so I'm going to integrate only x. Okay, x equal to 2. This is for x. Let's go for the integration with respect to dy. Okay, as I said, you're integrating with respect to y, so e to the 2y and 4 minus y, I cannot integrate it, right? It is not a constant this time. But if I start with integrating with respect to x, yes, so I have to reverse dy with dx. How I can reverse dy by dx? Depends on my area, right? My region. I'm not swapping like just, you know, put this one first and put the second one first. No, it depends on the, so I'm going to swap dy with dx. Okay. Now how I do this one? To find the value, to swap it, so you will start with dx dy instead of dy by dx. You will still have the same function, x e to the 2y over 4 minus y, but the boundary of the integration will be changed because I change dy with dx, but I'm not to take it as it is, right? Depends on this region. I start with dx, so how to find the lower bound for dx? Yes, I go horizontally, so I hit first the y-axis. This is the start of my region, so the x here will be start from 0. Yes, so I put 0, and then I go down up to the curve, so I hit the curve, the parabola. I know the relation between y and x, y equal to 4 minus x squared, so x will equal to what? 4 minus y, sorry, 4 minus y, I will change it again, sorry, it will be 4 minus y, not 4 plus y. Okay, so x will equal to the positive or negative root square of 4 minus y. Okay, y at, yes, I'll take the positive. As I hear you, I will take the positive because my area is above x-axis.
Doctor, it's x square equal 4 minus y.
Yes, I said 4 minus y, so this is why I'm going to correct it. Okay, don't worry, I'll correct it. Okay, good. Okay, don't worry about it. Yes, okay. Yes, x from 0 to root square of 4 minus 1. What about y? I'm not worried about the outside one because, as I said, once you find the lower bound and upper one for the inside one, you go for the outside one. The outside one is y, so I go vertically from the down to up, right? So I start from down, so I hit first the x-axis. In the x-axis, y is 0, so I will start with y equal to 0. Okay, and I hit the curve, but I'm not caring about the curve. I'm caring about the minimum value of y first and the maximum value of y last. Okay, so I start from 0 and the maximum value of y is 4, so I'm set again and again and again. The outside value must be constant. This constant, I am caring about the inside one only, right? So it will be the outside one will be the minimum value is the lower bound and the maximum value is the upper bound. Yes, now as I said in the beginning, if I am integrating with respect to x, I don't care about the stuff with y only, right? So I'll take e to the 2y over 4 minus y as a constant, and what's left? X. So I can integrate x with respect to x, which will be x squared over 2. Great. Now, don't forget to substitute the value, the upper bound of x and the lower bound. The upper bound is 4 minus y under the root square, and the lower bound is 0. So remember, when you substitute x by root square of 4 minus y, and when you square any root square, you get rid of it. So you will have 4 minus y only. Again, yes, because of the square, I get rid of the root square, so I have 4 minus y over 2. This is a substitution for the upper bound. The lower bound is 0, so if I put x equal to 0, I have 0. Now, yes, it is clear why I'm reversing the order of the integration, to cancel this one out with this one. What's left now? Only the integration of e to the 2y over 2 dy. You can do it by the calculator, or it is easy, you can do it by hand. Also, to integrate the exponential function, you need the derivative of the power to be down this exponential function. As an integration by substitution, if you take 2y as u, du will be 2, so you have eu du, which is e to the u. U is 2y, so you have the integration of e to the 2y over 2 will be e to the power 2y. Don't forget to substitute by the upper bound first, y equal to 4, minus the substitution of the lower bound, which is 0. Okay, so you have e to the 8, because y is 4, 4 times 2 is 8, minus e to the power 0, which will be 1. I think now you understand how to reverse the order of the integration and how to find the new lower bound and upper bound, depends on the region or the area you're integrating over.